Hello, so we are now on 9.9. Last lesson, 9.8, was just like a review of all the different formulas for volume and surface area that we've talked about. And we've talked about almost all of the 3D shapes. The only one that we're missing so far is a sphere. So that's what this lesson focuses on. The first thing that we're going to cover is just the different parts of a sphere, which are pretty similar to terminology that we use for circles, just because a sphere is just a 3D version of a circle. So that point in the middle, we would call that the center. Anytime you have the length from edge to edge, just like with a circle, that's called the diameter. If you have a line going from the center to the edge, that's called the radius. And then whichever circle is cutting through the center or the middle of the sphere and cutting it into two equal parts, that's called the great circle. And those two equal parts are called hemispheres. Maybe you've heard that word before when we're talking about like the Earth. We're here, we're part of the northern hemisphere. The southern hemisphere encapsulates like South America. So we'll talk about hemispheres a little bit later in the lesson. The formulas for volume and surface area of spheres are provided here. They're pretty similar to the stuff that we've seen earlier in the unit. So like for volume, all we're going to do is take 4/3 times pi times the radius and then cube that. So getting the cubed is not too difficult on the calculator. You just have to use the exponent button. So it's that button right under the word clear, the little up arrow. If you press that, that's the exponent button, and then you can just press a 3, and that's what gets you the cubed function. So let's try number 1. I would do 4/3 times pi times 7 cubed. And then I just have to type that in the calculator and find out what the volume is. That would come out to 1,436.76. And then whenever we're talking about volume, our units should be cubed, so inches cubed. Number 2, we would do similar process. The only thing is we need to find out what the radius is before we can find the volume. If the diameter is 33, the radius would just be half of that. 33 divided by 2 is 16.5. So the volume is going to be 4/3 times pi times 16.5 cubed. And then you would type that into your calculator and find out what the volume is. Don't be surprised if you get some large numbers today, just because volume, whenever you're cubing something, that tends to make the numbers really big. This one comes out to 18,816.57 centimeters cubed. Next, let's do some examples of surface area. The formula for surface area is also pretty straightforward. It's just that 4 pi r squared. So on number 3, our radius is 2.8, and then we square that. So you just type that into the calculator, and then that gives you the surface area of the sphere, 98.52 meters squared. So number 4 has the similar problem where they're given us the diameter and we just need to calculate what the radius is. So we would take 24 divided by 2, that gives us 12. So to find the surface area, we would do 4 pi times 12 squared. And when you type that in, you get 1,809.56 millimeters squared. All right, so we will also practice with some hemispheres. A hemisphere is just half of a sphere, and if you think about finding the volume of a hemisphere, it would really just be half of whatever the volume you would get from finding like the full sphere. So that's why it goes from 4/3 to 2/3. With the surface area, it's not as straightforward as that, because we're adding this little part on the top that we didn't have before, and so that's why it doesn't go from 4 to 2, it just goes down by 1, 4 to 3. But other than that, the formulas are almost the same. And remember, the difference between these two, volume is talking about inside the shape, so if you were to fill it or want to know how much space is inside of a shape, and then surface area is talking about the outside, so everything that's on the surface. So let's find the volume of this hemisphere. So we would just do 2/3 times pi times 5 cubed. Make sure you include that little 3 at the end there. That would come out to 261.8 kilometers cubed. And let's go to the next page. Let's do number 6. It just has that problem again where we need to find the radius ourselves. If the diameter is 18, the radius would be half of that, which is 9. So the volume is going to be 2/3 times pi times 9 cubed. So this should come out to 1,526.81, and then we're going to label it as feet cubed. I'll rewrite this formula for surface area over here. It was 3 pi r squared. So for number 7, it's really straightforward. We would just do 3 pi times 14 squared. And then type that into the calculator. You end up with 1,847.26 yards squared. Number 8. Once again, we just need to find out what the radius is. If we know the diameter is 12.2, half of 12.2 is 6.1. So the surface area would be 3 times pi times 6.1 squared. That comes out to 350.7 centimeters squared. And that's it for those. So those are pretty straightforward. Let's just practice some word problems now where we have to apply these formulas and think a little bit more about what exactly they're asking for. It's not as straightforward as the ones we were doing before. Like number 9 says, find the volume of a sphere with a great circle of 201.06 square inches. So we don't know anything about the sphere other than the great circle area. If we think about the formula for volume of a sphere, it's the one that was 4/3 times pi times r cubed. So the only measurement we need to find the volume of a sphere is the radius, and we don't have that. All we have is the great circle area. Well, if you think about how we find area, the formula for area of a circle is pi r squared. So that means that if we plug in the 201.06 in for area and set that equal to pi r squared, now we have an equation that we can solve for r, and that way, whenever we get for r, we can then plug in to our volume formula. So the way that we could solve this equation for r is just by trying to get rid of all this stuff that is bothering r. So r squared is being multiplied by pi, so let's divide by pi to both sides. And then the r is being squared, so the opposite of that would be to take the square root to cancel that out. And so you just have to square root everything that's on the other side. So in your calculator, let me make that a little bit more of a square root, you would do square root of 201.06 divided by pi, and just make sure that everything goes under the square root. And that way you get a nice clean answer for r. It comes out to 8. So now we can plug that into our volume formula. Let's do 4/3 times pi times 8 cubed. And once you type that in, you end up with 2,144.66 inches cubed. So number 10 says find the surface area of the figure to the left. The figure on the left could be called a composite figure. It's just one of those shapes that is made up of multiple shapes. So this one, our strategy should be to divide it into smaller shapes that we do know how to find the surface area of. So like this shape on the top could be considered a cone, and we know the formula for surface area of a cone. On the bottom, we have a hemisphere. We also know that formula. So we can just kind of think of them separately at first and then combine them towards the end. So the formula for surface area of a cone is pi r squared plus pi r times the slant height. So let's find out what that is. It's going to be pi times the radius. We just need to find that. If the diameter is 9, the radius would be 4.5. So pi times 4.5 squared plus pi times 4.5. And then remember the slant height would be the height that has a slant to it, so that's 13. And then you could find out what that is by just typing all of that in one line. This comes out to 247.40, or we can just leave it as 4. And then let's find the surface area of the hemisphere. That's the formula we were just using, the 3 pi r squared. So 3 pi 4.5 squared comes out to 190.85. So let's go off to the side to figure out what the total surface area is going to be. One thing that we have to remember is that surface area is only asking for everything that's on the surface. And if you think about these two different shapes separately, the cone, for example, everything that's on the surface is around it and on the bottom, underneath this circle. And then same with the hemisphere. If you were to think of that separately, it would be everything that's the rounded part, and then the flat top of the hemisphere would be considered part of the surface. But once we merge these shapes and put them together, that part, that little circle, is no longer on the surface, it's more on the inside of the shape. And so we shouldn't count it as part of our total surface area. Up to this point, we have counted it. It was considered part of this, and it was considered part of that. So we just need to subtract this area of that circle from our total in order to get the total surface area. So we can start by calculating the area of that circle. It would be considered the great circle of the hemisphere. So I'm just going to write area of great circle. The formula for area of a circle, we know, it's just pi r squared. So we can do pi times 4.5 squared. Find out what that is. That gives you 63.62. And then remember that we counted it twice. We counted it as part of the cone and as part of the hemisphere. So I'm just going to make a note to subtract 2 circles from our total, 2 of these 63.62 areas. So when we find the total, it's going to be 247.4 plus 190.85 minus 2 parentheses 63.62. And that should give us 311.01 meters squared. We're talking about surface area, so the units would be squared. Number 11 says that the Henleys have a silo on their farm to store grain. Assuming the entire space is used, what is the maximum amount of grain that the silo can hold? So we're talking about how much space is inside of the shape, and we're filling it with something, with grain. So whenever you're talking about filling a shape or however much space is inside of it, you're being asked to find the volume. So we want to find the volume of the shape on the left. Again, this is a composite figure, so we need to divide it into 2 shapes. The shape on the top would be just a hemisphere, and then the shape on the bottom would be a cylinder. So let's find each of those separately. First, the volume of the hemisphere is going to be the 2/3 times pi r cubed. So our radius is going to be whatever half of 22 is, that's 11. So pi 11 cubed. And that comes out to 2,787.64. And then the volume of our cylinder, we need to remember what that formula is. We talked about that one a couple lessons ago. That one was simply pi r squared times height. So let's use the measurements that we know from the cylinder to find out its volume. I'm going to do pi times 11 squared. The radius of that is still 11. And now I just need to calculate the height. The height of the cylinder would be from here to here. And we know that all of this is 45. So I just need to kind of subtract this part, which would be 11, because we know that from the center to the edge is 11, and that would apply in any direction that you go, even if you're going up. So we just need to take 45 minus 11. That would give us 34. So our height is 34. And now we can find the volume by doing pi times 11 squared times 34. That comes out to a pretty large number. It's 12,924.51. And then to find the total of how much space can fit in this silo, we would just add these numbers together. This time you don't need to subtract that little circle where they meet, because that only applies to surface area when you want to know only the stuff that's on the outside. For volume, you do want to know everything that's on the inside, so we would count that. So when you add these numbers together, you get 15,712.15 feet cubed. Remember, whenever we're talking about volume, the units are cubed. So that's it for this lesson. Make sure to complete the exit ticket and the homework, and we are almost done. We just have a couple more lessons to go.